Good morning class. Today we discuss electron gain enthalpy. Student, electron gain enthalpy is defined as the energy released when a neutral isolated gaseous atom accepts an electron to form an ion. That is the amount of energy released when isolated gaseous atom accept an electron to form an ion is called electron gain enthalpy. Electron gain enthalpy is shown by delta EGH. Here the EG indicate electron gain, H indicate enthalpy. Delta indicate change. That is electron gain enthalpy is defined as the amount of energy released by gaining an electron in isolated gaseous atom to convert it into an ion. Now it should be noted for many element energy is released by accepting a electron. That is why electron gain enthalpy is generally negative. Group 17 elements show high negative value of electron gain enthalpy because they have a strong tendency of accepting an electron to complete its octet to acquire noble gas configuration. But on other hand, noble gases, that is group 18 elements, show positive value of electron gain enthalpy because on addition of an extra electron goes to the next higher quantum level, which leads to unstable configuration. It should be noted as the size of atom increases, electron gain enthalpy become less negative. Electron gain enthalpy of fluorine is less negative as that of chlorine because of its small size. Sufficient electron repulsion take place. Now the question arises, how would you say that the second electron gain enthalpy of oxygen is positive, negative or less positive as compared to first? Justify your answer. Student, when an electron is added to oxygen to convert it into O negative ion, energy is released. That means the first electron gain enthalpy of oxygen is negative. But when another electron is added to O negative ion to convert it into O double negative ion, energy is absorbed to overcome the strong electrostatic force of attraction, or thus the value of electron gain enthalpy comes out to be positive. That is, the answer is the second electron gain enthalpy of oxygen is positive. Now let us discuss electronegativity. Electronegativity is a tendency of an atom to attract a shared pair of electrons. It is not a measurable quantity. I repeat again, electronegativity is a tendency of atom to attract a shared pair of electron in a covalent bond. It is not a measurable quantity, but number of scales are there to calculate electronegativity. Pauling scale is one of them. It should be noted, fluorine is the most electronegative element known. Electronegativity decreases on moving down the group because the metallic character increases. Electronegativity mainly depends on two factors. The first one is the state of hybridization and the second one is the oxidation state of the element. Now let us discuss first one, state of hybridization. It should be noted, sp hybridized carbon atom show much more electronegativity as compared to sp2 and sp3 hybridized carbon atom. Second point is oxidation state of element. It should be noted, more the oxidation state of an element, more will be its electronegativity. For example, Fe3 positive has much more electronegative value as compared to Fe2 positive ion. Now the question arises, how would you react the statement that the electronegative value of nitrogen in all their compound is 3? This statement is correct, student. The electronegative value of nitrogen is 3 in all their compound. The statement is wrong because electronegativity depends on state of hybridization and oxidation state of an element. Now let us discuss Pauling scale. As we described earlier, Pauling scale is used to calculate electronegativity. Electronegativity is generally represented by letter chi. It is a difference between chi A and chi B. chi A and chi B is equals to 0.1017 under the root delta. Here the delta indicate EAB, that is bond dissociation enthalpy of AB minus bond dissociation enthalpy of AA into bond dissociation enthalpy of BB. With the help of this scale we can calculate electronegative difference between two elements. Now let us discuss valency. Valency is defined as the combining capacity of an element. The electron present in valence shell is said to be valence electron. It should be noted the first element of S and P block element show anomalous property. I repeat again, the first element of S and P block element show anomalous property due to four reasons. First one is they have exceptionally small size, they have high electronegativity, they have high ionization enthalpy, and also non-availability of vacant d orbital. It should be noted the first element of S block and P block show anomalous property due to four reasons: exceptionally small size, high electronegativity, high ionization enthalpy, and non-availability of vacant d orbital. Now let us discuss diagonal relationship. Students, first element of group 1 and group 2 show similarity in properties with second element of next higher group. I repeat again, first element of group 1 and group 2 show similarity in properties with second element of next higher group due to similar ionic size. This relationship is called diagonal relationship. For example, group 1 element, that is lithium, show diagonal relationship with magnesium. Again, beryllium show diagonal relationship with aluminium due to similar ionic size. Now one more question arises. It is given in NCERT. Show by a chemical reaction that Na2O is basic and Cl2O7 is acidic oxide. We have to prove that Na2 is basic and Cl2O7 is acidic oxide by reacting it with water. Now react it with water. When Na2O react with water, we will obtain NaOH, which is strong alkaline in nature. That show that it is basic in nature. But when Cl2O7 react with water, we will obtain 2HClO4. That show it is acidic in nature. Thank you very much.